So guys, let's start building AdaBoost classifier using Python. So what was the step 1? Importing necessary libraries. As of now, we will go with importing these two libraries and these two libraries. Import numpy as np, import pandas as pd, import matplotlib.pyplot as plt, import cbon as sns. These are basically plotting libraries. Now step 2 will be loading the dataset. So this will be step 2. Loading the dataset. So let us assume the data frame as df. Now pd.read_csv, this is the command, okay, and we have to copy the path name where this csv file is stored. Okay, so basically this is a csv file and this is the downloads folder where it has been stored, right? So let us execute it. How to execute? Shift plus enter. Okay, so now this is executed. Now what we will do, we will try to get first 5 rows of our dataset. So you can see here this CSV contains all these column names, okay, age, attrition, business travel, like they travel rarely or frequently, daily rate, okay, what are the department of the employees, okay, distance from home, what are the education, what is the field, okay, employee count, this is the employee number, so on and so forth. Okay, so you can see here there are many columns. Now let us go with finding out the what all columns are there and what are their data types. Okay, using df.info we can find out all the necessary information with respect to the data set. Okay, so there are total 34 columns and these are the data types of different columns, and these are the non-null count. What do you mean by non-null count? It means that there are no null values, right? And the memory usage is 402 kilobyte. Okay, using df.describe we can basically check the statistical parameter with respect to those columns which have numerical values, right? So count, mean, standard deviation, minimum, what is the minimum value, what is the 25th percentile, 50th percentile, 75th percentile, what is the maximum value, right? So all these data you can check with using df.describe command. Okay, you can also check if at all there is any null value. So df.isNull.sum, this will fetch you if the columns have any null values. So there are no null values, right? Now next we will see checking the number of yes and no in the data, right? So how you can check? You have to use cbon library, okay, and we assume this ax as the variable for plotting of cbon plot. Okay, so you take as x as the attrition, you can take any variable, and kind as the count, and data as the data frame. Okay, now when you hover over this cat plot, you can also see what this cat plot provides you, the different kind of commands, or you can say inputs. So we have used here count. You can see here in kind you have different literals like strip, swarm, box, while, box and point, bar count. Okay, so you can also play around with these different capabilities of these box plots. Okay, you can also put estimators, right, so that you can actually find out the mean of. So once you hover over this cat plot feature, then you can actually find out the different categories with which you can actually draw different kind of figures having different numerical values or different statistical data, right? So here we are checking the number of yes and no in the attrition, right? So you can see here yes are very less and no are approximately 1200 plus, right? Now our step 3 which we already discussed was feature engineering. So what we are doing in feature engineering, basically we are dividing numerical dataset and categorical dataset separately, We will deal with categorical dataset using one hot encoding technique, okay, and numerical dataset using scaling feature. After that we will concatenate. So let's do this. So using data frame, so this df is our data frame which we have assumed as the variable. If we give this command df.d types, then it will show us what all data set are integer and what all data set are object, right? You can see here. So what we will do, we will create different data sets, or you can say data frame for numeric type and categorical type. Okay, so let us consider numerical as df underscore num. Okay, how we can extract the numerical features, df dot select d types. Now you can see here, as soon as we put on the bracket, it is showing some commands, right? So what we can do, we can include or exclude, right? We can return. So these are all different action we can perform. So select underscore data types, include equals bool. Okay, this is how we can include the float. Okay, this is how we can include or exclude int, right? So for boolean we don't have to put the square bracket, right? But for float and int we have to put square bracket, and we have to tell Python whether we have to exclude or include, right? So you can see here, right? So df.select underscore d types, we will put include equals int 64 within bracket. Okay, so include int 64. Why we are putting int 64? Because see here we have int 64 and object, so other one will be object, right? Now what we will do, similarly df.select d types include object. Okay, right? So you can see here, let me execute it once. So here all the integer values have come, and here all the object values have come, whose data type is object, right? So this is how we can have different data set. Now let us put all this in a data frame, like we need to create a data frame. So what we'll do, df dot data frame, put this in bracket and just apply this like this. It is showing some error. Okay, we have to use this pandas. Okay, pd, put this pd. Okay, now it is taking. So we have created df.num. Now check what is df.num, sorry, df underscore num. So this is the dataset having 26 columns and 1470 rows, right? So this we have displayed first 5 rows. Similarly we can do here also, df dot cat for category dataset is equal to pd dot data frame and df dot cat dot head. Df put, you can put df underscore, and this also has df underscore. Now you can see here. So this is how we have actually done this. Now we have separated numerical values and categorical values, right? Now what we will do with categorical and numerical, for numerical we will do scaling, and for categorical we will do encoding. So let's do the next step. So first we will do encoding of categorical dataset. So in categorical dataset, let us so here in categorical dataset we have attrition also. So what is attrition? Attrition is y. Okay, means our target variable. Okay, so this needs to be separated. So what we are doing here is, we have created a data frame df underscore cat, wherein we actually need to go with those columns which are independent variables, right? Which are independent variable. Okay, so simply why we are taking it out, because we actually want to map these as 1 and 0. Okay, so dropping attrition right before processing of encoding. Okay, so df underscore cat equals df underscore cat dot drop. Okay, so now you can see here attrition is dropped. initially this was attrition was there, now attrition is gone. Now we will do encoding using get dummies function. Okay, so let us again assume df underscore cat underscore encoded, okay, is equal to pd dot get dummies df underscore cat. Okay, so this has been executed. Now let us check what is. Now you can see, so business travel, non-travel, business travel frequently, business travel rarely. Okay, so this have been encoded properly. Okay, department human resources, okay, department research and development. So these are all marriage or divorced, marital status, single, married, right? So these are all have been encoded. So this is our new data frame, df underscore cat underscore encoded, right? So on this we will do further simulations. Now the next is scaling the numerical feature. This was a step we had discussed in feature engineering. So let us scale the features. So for scaling the numerical feature, let us assume one variable df underscore num. Okay, so this is our variable underscore scale, right? So we will be using standard scalar df underscore num. Let us see. So now it is giving this command error, standard scalar is not defined. So basically before importing this standard scalar we need to import its necessary library. Okay, so what we will do, we will just insert import from sklearn.preprocessing import standard scalar. Okay, so here you can see standardization of dataset is a common requirement for many machine learning estimators, right? Standard scalar is sensitive to outliers and the features may scale differently from each other in presence of outliers, right? Now we can use these different parameters, copy, with mean, with standard deviation, std, right? Attributes, we can have different attributes as well, scale, okay, mean, var, n features underscore in underscore. Then we have to fit the data, right? We have to initialize standard scalar, right? So here standard scalar, then we have to do scalar dot fit df num. Okay, scalar is equal to standard scalar. Now df underscore scaled equals scalar dot fit underscore transform df num, right? Yes. So now we have scaled the df underscore num and the value is stored in df underscore num underscore scaled. So this is the scaled data. Now we can just check the scaled dot head. So this is the array. Now what we will do, we will convert this now dot head. Okay, now this is scaled. Okay, here you can see we have imported standard scalar. We have assumed a variable scalar for this standard scalar command. Now what we are doing here is we are doing fit transform on this scalar, right, over the dataset df underscore num, and we will rename this dataset as df underscore num underscore scaled. So when we have done so, what we have got is all these rows and columns having indexing. Okay, so here you can see there are indexing, here also you have indexing, right? So you need to convert these indexing into column names, right? So what we will do, we will further within this bracket we will further give commands of columns is equal to df underscore num dot columns, and here we will put some indexing attribute so that all these 1 2 3 4 up to the 25th column, they will take their own column names, right? So here we will put df underscore num dot index. Okay, now you can see here we have got these column names, right? So what we have done, we have this df underscore num underscore scaled, and we have converted this data into this data frame, and the column names which we initially had those indexing, that we have converted into all the column names using this command. So index equals df underscore num dot index. So what it will take, it will put the index which is same index as df underscore num, right? So this is what the command is. So now we have scaled the numerical features, we have done encoding. Now it's time to merge the two data frame. Okay, we will merge the two data frame. Assume transformed underscore final. So this will be our final data set. We have this concatenation command. So we have merged this two data frame, df underscore transformed underscore final. So this is the final data frame, pd.concat, scaled data set and categorical encoded data set. Okay, and we will make axis equals 1. So this is the data set. If we don't do this, so this is the merged data frame. Okay, so it has total 55 columns. So this transformed final data frame is our x. Okay, this is our x, but where is y? Means target data attrition, right? Attrition kahan par hai? So initially what we had done, after loading the data set, we had here we had dropped the attrition from df underscore cat. Okay, so extracting target variable from df. Okay, so let us consider target equals df attrition. Okay, so this is our target variable. You can also check yes no, right? So this is our target variable. Okay, now what we will do, we need to convert this yeses and nos to zeros and ones using function lambda. Okay, so target is equal to target dot, we need to apply, right? Apply lambda x such that yes is equal to 1, no is equal to 0, right? So this we have to, okay, so target equals target dot apply lambda x such that yes will map to 1, no will map to 0, right? Now let us check what target is, right? So yes is mapped to 1 and no is mapped to 0. Okay, so now we need to extract target variable from df, right? So assume this target equals df attrition. Okay, so this will extract the attrition column from df data frame. So you can see here this is the target underscore head, and we need to map the yeses to 1 and nos to 0. Okay, so target is equal to, we will be applying the lambda function over this map. Okay, so target dot apply lambda x as that map of x. Okay, so this is the command. Now you can check what is target. Target is 1010, right? So all the yeses and nos are converted into ones and zeros. Okay, so now finally we have x and y, so we should make sure that we do not get confused. So what we will do, we will substitute the, so here x will be our transformed final, okay, and y will be our target. So y dot head you can check, x dot head will be these. Now we will import train test split, and what is x train dot shape is this, x test is this. Okay, so you can see here 70-30 ratio, this data set has been divided. Now y train dot shape, this is only one column, y test dot shape, this is y test. Okay, so now we are ready for model building. So this we have done, train test split. Now step 4 will be model fitting. So we're gonna fit the AdaBoost classifier. So for that we have to import the AdaBoost classifier. Okay, from Scikit Learn dot ensemble import AdaBoost classifier. Okay, so in model fitting, what we have studied in our theory lecture was, we need to provide a base estimator, we need to provide an underscore estimator, and we need to provide the learning rate. So these three inputs or parameters we have to provide for model fitting the AdaBoost classifier. Okay, and after fitting the model, we need to check the accuracy score and confusion matrix. So that for these also we have to import from the necessary libraries. So let us start importing the libraries. So from sklearn dot matrix import accuracy score, comma confusion matrix. Right, now let us fit the model AdaBoost. So model is equal to AdaBoost classifier. Okay, so model dot fit. Okay, and we have to give different parameters, right? So we have to give the parameters. So model dot fit, we have to give the parameters x train comma y train. Okay, so here it will fit the model. So we have to provide the inputs, right? We have to provide the parameter. So you can see here an estimator, learning rate, okay, and algorithm also it is given different algorithms. Random state we can see base estimator. Okay, so let us give only a number of trees which we want. Okay, so n underscore estimator we can take it as 200 and random state equals 1. Okay, now we will fit. Okay, so this is the algorithm which it has automatically taken. Algorithm is deprecated, random state is 1, learning rate also it has taken 1, and n estimator equals 200, right? So this is fitted. This AdaBoost classifier, this model is fitted. You can see here. This is the documentation for this AdaBoost classifier. What all the parameters. Now let's predict the y pred. Okay, so what we will do is y underscore pred. Now we will take this model. Okay, AdaBoost classifier. So this model dot predict. Predict on what? Predict on x test. Okay, so we will see we have y with us. Okay, y test. Okay, we have y test with us, and what we are predicting, we based on x test we are predicting y pred. Okay, so then we will compare the accuracy between y pred and y test, right? So let us execute it. Okay, this we have executed. Now let us create this accuracy score between y pred and y test, right? So what is the accuracy score? It is 0.875. So it is a very good accuracy score. Now what is confusion matrix? Y true comma y pred. So y true is y test comma y pred is y pred. Okay, so this is the confusion matrix. So this is all with respect to AdaBoost classifier. So let us quickly revise. First we'll import the necessary libraries for plotting. We will load the dataset. We will check whether there is any missing values. When there is no missing values, we will go for checking the yes and no in the data, right? So we will have a broad idea of the attrition, okay, in a company. Step 3 will be feature engineering. In feature engineering, we will be dividing the data set into numeric type and categorical type. For categorical type, we will do the encoding, and for numeric type, we will do the standard scalar. Okay. After that, what we will do? We will merge the two data frame, right? Okay. So we will merge the data frame and we will extract the target, right? We will convert this target variable or y in yes and no. I mean, it is already in yes and no. We will convert it in ones and zeros, right? Further, we will go for train test split and later on model fitting. Okay. So this is how there are different steps which we had already discussed. Here we are getting the accuracy score of 0.87, which is fairly good. Okay. So our model is good fit. Okay. So we can give the summary. Our model is good fit. Okay, right? So thank you everyone. Keep watching my videos and keep subscribing to get more and more such videos. Thank you.